Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will try to understand how to solve the problems based on the nodal analysis method. In the previous video I have discussed about the basics of the nodal analysis method, its statement and its explanation part. Now here I will cover the basics and then we will move. In this method, it is assumed that the statement of the nodal analysis method is that in this method, it is assumed that we have to mark the nodes first. Now here, in this case, we will mark the nodes. This is one node, this is the second node, and this is the common node, right? Because node is a point at which three or more than three branches meet together. This is 1, 2, 3. This is 1, 2, 3. Here is 1, 2, 3. Here is 1, 2, 3. But here we cannot treat it as two separate nodes because whenever we don't have any element between the two nodes, then we will consider it as a single node itself. And here we will assume the potential of this particular node as a 0 volt and it is treated as a reference node. Now here we will assume this node as a node A with potentials VA. We will assume other node as a B node with potential VB. And in case of nodal analysis method, we have to assume the separate current for the separate branch. Now here in this case, again there comes a definition branch. Branch is the path between any two nodes. Here this is one node and this is other node B. Then this particular path is nothing but the branch. Here for branch 1 we will assume its current as I2, for branch 2 we will assume its current as I2, for branch 3 we will assume its current as I3, for fourth branch we will assume its current as I4, and for the fifth branch we will assume its current as I5. First important thing in case of the nodal analysis is that we have to assume the separate current for the separate branch. Now here, then we will apply the KCL, that is Kirchhoff's current law in this particular case for the node A. Now here, applying KCL at node A, we will prepare its equation. If we are applying the KCL or Kirchhoff's current law at the node A, the KCL will be something like this. Here, in this case, KCL is incoming currents is equal to outgoing currents. Here, I1 is incoming, I2 and I3. These two currents are outgoing. That's why its equation will be this I1 is equal to, here the KCL will be the I1 is equal to I2 plus I3. Here, it is I2 plus it is I3. Now, we will find out the value of the current I1, which is nothing but potential difference of this branch divided by resistance of this particular branch. Here is a potential 0, we are traveling in this direction, negative to positive, that is a plus 10, minus the potential here at this node, which is VA divided by resistance of this complete branch, which is the 3 ohm, which is equal to I2. I2 is the current in this vertical branch, VA minus 0 divided by its resistance. Here it is VA minus 0 divided by its resistance, which is 6 ohm, plus I3. I3 is the current in this horizontal branch, that is VA minus VB divided by its resistance, that is VA minus VB divided by its resistance, which is a 5. This is, we will simplify this equation and we can name this equation as equation number 1. Its simplification will be something like this, that is 10 divided by 3, it is minus VA divided by 3, which is equal to, it is VA divided by 6 plus it is VA divided by 5 minus it is VB divided by 5. This will be the equation. I will shift this VA term on the next side and we will take it as a common. Then it is a VA in bracket. It is 1 divided by 3 plus it is 1 divided by 6 plus it is 1 divided by 5 minus it is VB divided by 5, which is equal to 10 divided by 3. We will call this as equation number 1. Now here we have applied the KCL at node A, and now we are planning to apply the KCL at the node B because we have the two unknown, that is V and VB. We will apply the KCL, that is Kirchhoff's current law, at the second node, that is at node B, and we will find out its equation. Now here, applying KCL at node B, applying KCL at node B. If we are applying the KCL, that is Kirchhoff's current law, at the second node, that is at the node B. If we are applying the KCL at node B, its equation will be something like this. For the node B, we have I3 is incoming, I4 is outgoing, I5 is outgoing. This equation will be at node B, I3 is equal to, it is I4 plus it is I5. Then we will simplify further. I3, we will find out its value of the current by using potential difference formula, that is VA minus VB divided by its resistance. This here it is VA minus VB divided by its resistance, which is 5, which is equal to I4. I4 is the current in the vertical branch, that is VB minus 0 divided by 8. Means it is VB minus 0 divided by 8 is resistance plus I5. I5 is the current in this branch. Here is the potential VB. We are traveling from negative to positive, that is a plus. That is VB plus 5. Then we are coming here, that is minus 0 divided by or plus 0 divided by its resistance, which is 2. If we are simplifying further, it is VA divided by 5 minus it is VB divided by 5, which is equal to VB divided by 8 plus it is VB divided by 2 plus it is 5 divided by 2 is the equation. Now if we are shifting these to VB on the first side and taking it as a common, then its equation will be, it is VA divided by 5 minus VB is a common. This is VA. In bracket, it is 1 divided by 5 plus 1 divided by 8 plus it is 1 divided by 2, which is equal to, this is 5 divided by 2. This is the equation number 2. Now we have the two equations and two unknowns. Now solving the equations, now here this way, this may be some constant value, that is 0.6 or 0.3, something like that. It is 1 divided by 5, it is 0.2 VB, and it is 10 divided by 3, some constant, means we will get the equation something of this kind. It may be, these values may not be the correct, this may be the 0.2 VA something minus 0.2 VB something, which is equal to 10 divided by something, means it may be, that is 3.33 something. And we have, this is one equation, and similar equation we will get from the equation number 2, and then we are able to calculate its values. Means solving these equations simultaneously, we are able to find out the values of the current, values of the potentials, that is VA and VB, and by knowing the values of the potentials VA and VB, we are able to calculate current in all branches. Here the I1 can be calculated by using this, I2 can be calculated by using this formula, I3 similarly formula for I4 and I5 is in this way we are able to calculate current in all branches by using this, that is nodal analysis method. Now here similarly I will increase the complexity level a bit and we will try to find out the current in all branches by using the nodal analysis method. Now here in this case we have the three nodes. Here it will be the node 1, this is the node 2, this will be the node 3, and this will be the node number 4. We cannot treat these two nodes as a single node because here is the element is existing, that is 2 ohm. Out of this available 4 nodes, one of the node is treated as a ground node. I will treat this node as a ground node. I will assume its potential as 0 volt. Then here assume the separate current for the separate branches. We can assume any direction again. I am telling again and again, we can assume any random direction. Here I will assume this direction opposite as that of the previous. This is I2, this may be the I3, here it may be the I4, here this may be the I5, and here this current may be the I6. Because we have 6 branches in this particular case. Assume any random directions. There is no difficulty on assumption of the directions of the current. If we are applying the KCL at node A, here this is node A having its potential VA, this is the node B having its potential VB, this is the node C having its potential VC, and this will be the ground node. Or you can assume this is as a ground, this is as a VC, this is as a ground, or ABC and so on. If we are applying the KCL at node A, KCL will be this is incoming, this is incoming, this is incoming. That's why its equation will be I1 plus it is I2 plus it is I3, which is equal to 0 will be the equation at node number A. If we are simplifying this equation further, it will be something like this. Here is the potential VC. This is VC. We are traveling in this direction, negative to positive, which is a plus. Its voltage is 20 minus this potential, which is VA divided by its resistance, that is 2 plus 2, 4, 4 plus 3. 7. Now here this is 7 plus I2. I2 is the current in this branch. We have taken its direction upward, means this is higher potential, this is lower potential. If we are assuming direction downward, reverse is the case. This is higher potential, this is lower potential, minus VA minus VB in that case, and in this case the potential will be, we are starting from here, this is VC, this is VC, we are traveling from positive to negative, that is minus 2, minus this potential which is VA divided by its resistance which is the 8 ohm, plus I3. I3 is the current in this branch. This is higher potential, means this value will be, this is VB plus 3, because we are traveling from the negative to positive, that is a plus, minus its potential, that is VA divided by its resistance which is the 5 ohm. Now here this is the equation. In this particular case, we can simplify this equation and we can have its values. That is that will be the equation number 1. If we are applying the KCL to the node B, this is the node B. KCL will be incoming currents is equal to outgoing. This is incoming, this is outgoing, and outgoing, this equation will be I6 is equal to, that is I4 plus it is I3. I6 is directly known, which is 5 amperes, which is equal to I4. I4 is the current which is downward, that is VB minus 0, or VB, we are traveling from positive to negative, which is VB minus 3, then minus 0 divided by its resistance which is 5, plus I3. I3 we have already calculated, which is VB plus 3 minus VA divided by its resistance, that is 5. This is the equation at the node B. We can simplify this equation and we can have equation number 2. From this we can have equation number 1. From this we can have equation number 2. And similarly, if we are applying the KCL at node C, at this node, here I2 is outgoing, this I1 is outgoing, I5 is also outgoing. This equation is incoming currents is equal to outgoing currents, and here in this particular case incoming current is 0. This 0 is equal to all are the outgoing currents, that is I1 plus it is I2 plus it is I5. We can simplify here. The value of the I1 will be, already we have calculated its value, otherwise we can find out once again here. In this case we are taken the direction of the current upward. This is VC plus 20 minus VA. This will be VC plus 20, this is 0 is equal to, again 0 is equal to VC plus 20 minus VA divided by its resistance, that is 7, plus I2. I2 is the current in this branch which is upward, VC minus 2 minus VA, VC minus 2 minus VA divided by its resistance which is 8, plus I5. I5 is the current in this particular branch, that is VC minus 0 divided by its resistance, that is VC minus 0 divided by its resistance, which is the 2 in this particular case. We can simplify this equation, and here which is equal to 0 again, because this value is equal to 0, here we have 0, and from this we can have equation number 3. If we are simplifying this, we can have equation number 3, and by solving these 3 equations simultaneously, we are able to calculate the values of the potentials. Here VA, we are able to calculate the value of the potential VB, value of the potential, and VC. And by knowing these potentials, we can find out its values of the all currents. That is nothing but here it is current I1, current I2, current I3, current I4, current I5, as well as its current I6, which is already known, which is as 5 amperes. Means in this way, here we are able to calculate I1 by this formula, I2, there will be the I3, this will be the I4, then this will be the I5, and here we are already aware of the current which is I6 here. This is the current, means in this way we are able to calculate all the currents by using this particular method, which is nothing but the nodal analysis. Again here I am telling that I am not taking the care